Hey, good afternoon. How are you doing? आज है लास्ट सेशन किनेटिक्स का. सो वेदर यू प्रिपेयरिंग फॉर जेई, नीट और एनी अदर टेस्ट जो इंडिया में है, दिस इज डेफिनेटली गोइंग टू हेल्प यू. सो व्हाट हैव वी कवर्ड सो फार? इट मे लुक लाइक बहुत ही कम बचा है, राइट? इफ आई शो यू द एनसीईआरटी, व्हिच आई विल डू राइट अवे, राइट? विल स्टार्ट ऑफ द बैट, राइट ऑफ द बैट. आई विल शो यू एनसीईआरटी में कितना कवर किया है, हम लोग क्या करना बाकी है. सो फ्रॉम एनसीईआरटी लुक्स लाइक बहुत छोटा टॉपिक बचा हुआ है, बट इस टॉपिक पे सवाल आते हैं, काफी बार आते हैं. सो किनेटिक्स में देयर आर प्रॉब्ली टू टाइप्स ऑफ क्वेश्चंस दैट कैन कम, थ्री ब्रॉडली, राइट? फर्स्ट इज फ्रॉम द फर्स्ट पार्ट ऑफ किनेटिक्स, सेकंड वो जो रेट एंड ऑल ऑफ दैट. सेकंड वन इज इंटीग्रेटेड रेट लॉ. पहला डिफरेंशियल रेट लॉ, इंटीग्रेटेड लॉ, और तीसरा वाला ये टेम्परेचर वाला चीज है, टेम्परेचर कैटलिस्ट लॉ. सो वी दैट्स व्हाई देयर इज अ होल सेशन ऑन दिस. अगेन एनसीईआरटी में लुक लाइक बहुत छोटा सा पार्ट बचा है. I'll show you right away. Look at this. See, this NCERT says कि हमने ये सब ऑलरेडी कवर कर चुके हैं. Hi Sid, hi Teethraj, how you doing? Sid, you're in 11th, you're still attending, okay, great. Teethraj, Krishna, pranam, hello, hello, hello. Can you guys hear me and see me clearly? Hey Devanshi, wow, long time Devanshi, how are you doing? Chandrasekhar, pranam, namaste. Looks like Sunday is a good time for you guys, huh? A lot of you are showing up. Okay, great. Excuse me. So all of these things we've already covered, okay? देखो हम लोग सब कुछ कर सकते हैं, डिफाइनिंग कर चुके हैं. एवरेज इंस्टेंटेनियस रेट ऑफ रिएक्शन इन टर्म्स ऑफ चेंज इन कंसंट्रेशन, ब्ला ब्ला ब्ला, ये सब कर चुके हैं. एलिमेंट्री कॉम्प्लेक्स रिएक्शन में मॉलिक्युलरिटी ऑफ द स्लोएस्ट स्टेप इज ऑर्डर. इस इनफैक्ट जेई एडवांस में इस पे सवाल आया था. जेई एडवांस में, वुड यू बिलीव इट, जेई एडवांस में एक बहुत ही वेरी वेरी डूएबल क्वेश्चन आया था. खैर, and differentiate in molecular in order, we have done that. Define rate constant, सब कर चुके हैं. Only the stuff in brackets we'll do. So what are we going to cover today? Let's quickly look at NCERT and then we'll get started. ठीक है? NCERT का page number what? Hold on one moment so that you know you have all this has been done, okay, in the first three sessions. यहाँ से this is where we're going to go, right? 4.5. This is what is happening in today's session. ठीक है, मेरे सर के जस्ट ऊपर है. I'm good. How you doing? Neetu, hello, hello, Punya. Happy Sunday to you too, Aditya. Devanshi, how are you doing? Long time. So this is what we are going to be doing, right? Hey, why is this showing you my screen? It's supposed to show you my window. ये क्या हो रहा है भाई? इसमें लिखा है विंडो. आई रुकिए, ऑटोमेटिक बिट. अरे यार, something weird happened. Is it gone? No, it's still here. Okay, great. It's for some reason showing my whole screen. Not that it matters, but it's weird to see all those icons at the bottom. Okay, we will look at this. Okay, that K, which is this awesome rate constant. Rate constant depends on temperature. Okay, this is looks like the equation looks a little weird. हम लोग उसको discuss करेंगे. Yeah, but this basically means if I increase temperature, K will always increase, which is very interesting. हमने देखा था capital K may increase or decrease depending on whether delta H is positive or negative. You remember this? And what is capital K? Capital K was KF by KB. यार मैं बुक पे लिख सकता हूँ, ठीक है, बिकॉज इज ऑनलाइन बुक. प्लीज अपनी असली बुक में ये सब मत लिखना, ठीक है? दिस इज गुड फॉर स्क्रिबलिंग ऑन, दिस इज एज, इट्स वंडरफुल, यू कैन राइट इट इरेजर, जो भी है. तो ये सब बात विल डिस्कस. दिस इज द probably the most important part, most practical part of this session, which is also useful in KTG, kinetic theory of gases, and also from states of matter, जो आपके सिलेबस से हटा दिया गया है, बट ठीक है. These two ideas, these two graphs. And then the last part of this graph, this is this, hold on one moment, this graph right here also is what we'll talk about. Yeah, what's this K, we just took log on both sides, then you get a straight line graph. Last part is catalyst. ठीक है, catalyst में 2-2.5 pages यहाँ पे है. That's it, and the chapter ends over here. So your biggest thing is after this chapter gets done, आप लोग ये सारे सवाल करोगे. कुछ 30 सवाल हैं, I think 28-30 questions, right? Let's see. हाँ, 30 questions, exactly 30 सवाल हैं. Please solve these questions. Exemplar के सवाल solve करें, you'll be good. चलो आज की क्लास शुरू करते हैं. I'm in chill mode today because it's an awesome Sunday. And what? Did I do something funny? Oh, I clicked display capture. That is what was weird. Anyway, we're back to this. That's why that was happening. All right. ग्राफ आया था इस साल, देखो नीट में भी आया था, बोल रहे हैं स्टूडेंट्स. या दैट्स हाउ इट इज, राइट? वेदर यू आर डूइंग जेई, नीट, कोई भी एग्जाम कर रहे हो, किनेटिक्स से सवाल आते ही आते हैं. एंड जेई मेन में तो जनवरी और अप्रैल अटेम्प्ट में दोनों टाइम आए थे सवाल फ्रॉम किनेटिक्स. एंड जेई एडवांस में भी सवाल आए थे किनेटिक्स, बिकॉज किनेटिक्स इज द मोस्ट प्रैक्टिकल thing you're going to learn from the whole of chemistry. Like every reaction that you study, every process that you do, in even in biology, whether you're doing it as doctors, कोई भी चीज कर रहे हो, आप टाइम के साथ चीजें स्टडी करते हो, so it will be useful. Anyway, what is the effect of temperature? That's what we're going to look at first. ठीक है, ये है जनरल आइडिया कि जो भी अगर ये होता है ना, हम लोग खाना फ्रिज में क्यों रखते हैं? खाना फ्रिज में रखते हैं ताकि टेम्परेचर कम हो, ताकि वो रॉट ना हो. दैट इज ऑल्सो a physical process, chemical process, right? So everything you do has something to do with टेम्परेचर, और टेम्परेचर जहां कम हुआ उसका रेट रिएक्शन का स्लो हो गया। लोग बोलते हैं ना कि क्रायोजेनिक्स करेंगे, वी विल फ्रीज आवर बॉडीज एंड वी विल वेक अप आफ्टर 100 इयर्स, ये सब ड्रामा जो करते हैं, इट्स द थ्योरी इज द सेम। दिस इज अ इंटरेस्टिंग स्टैटिस्टिक, ठीक है। यहाँ पे कुछ लिखा था स्क्रीन पे, आपने पढ़ा क्या ध्यान से? विल पुट दैट, आई विल पुट दैट बैक हियर। इट सेज कि 10 डिग्रीज राइज से रेट कांस्टेंट डबल हो जाता है। हाउ? ओके, विल लुक एट दिस, विल लुक एट द मैथ बिहाइंड दिस वेरी सून। इन द नेक्स्ट 10 मिनट्स विल लुक एट द मैथ बिहाइंड दिस, ठीक है। लिटरली 10 मिनट में हम लोग इसको करेंगे, ठीक है। ऑल राइट, द Arrhenius was the awesome chap who figured this out. This is the same Arrhenius, by the way, the acid base के थे, उन्होंने ये figure out किया। This was the expression जो NCERT में दी थी। He figured out this relationship. A is a frequency factor, and इसकी unit क्या होगी, by the way? The unit of frequency factor is going to be same as K. Okay, I'm going to write that down बड़े-बड़े शब्दों में यहाँ पे। Unit of A is same as that of K, क्योंकि exponent के अंदर जो चीज है, there is no unit. Which also means कि EA will have the unit of RT, which is obvious, like EA तो energy unit है, तो ये सब chill है। But please go into these details, okay? ध्यान से ये सब समझिए, तब आपका लाइफ आसान होगी, ठीक है। Please don't try and mug all of these things. And this is a direct consequence of stuff in thermodynamics itself. All right. 3 क्वेश्चन आए थे, हाँ 2 करेक्ट किए, बहुत सही, वेरी नाइस थी, ग्रेट टू नो, ग्रेट टू नो। यू गाइस एबल टू हियर मी एंड सी मी क्लियरली, राइट? आई गेस यू आर, बिकॉज सब लोग हेलो हाय बोले थे, तो आई एम गेसिंग दैट इज गुड, ठीक है, कूल। Just checking in, ठीक है। थोड़ा बहुत थ्योरी करेंगे, we'll keep doing some questions as well. Give me thumbs up in the chat just to know that everything is good. Okay, cool. So कोई भी रिएक्शन लीजिए, एक एलिमेंट्री रिएक्शन, ठीक है। If you want to go over stuff here, this is called a pre-exponential factor and also the frequency factor. We will talk about this when we talk about collision theory in some detail, ठीक है। Towards the end of this chapter हम लोग इसकी बात करेंगे। Right now we'll focus on this, the activation energy and the temperature, ठीक है। इन दोनों चीजों पर हम फोकस करेंगे। तो इस रिएक्शन कब होगा? दिस रिएक्शन विल हैपन इफ these two guys collide, A2 and B2, and they collide at an orientation that makes sense, and they collide with enough energy. There are 3 things. Okay, one is that they should collide. Second thing is that they need to reach a certain energy state to be able to do this. Okay, and the third thing is the orientation. Orientation बात हम लोग बाद में कर लेंगे. Okay, so maybe this is the initial state. Okay, right here, and this is the final state. मतलब this is maybe A2 plus B2. What are we doing? We are plotting energy on the y-axis and reaction coordinate, मतलब Q. What was Q? This is that same thing. You remember? Delta G is delta G naught plus RT ln Q. That reaction progress, same Q. Reaction coordinate, same चीज यहाँ पे लिखी है. So this looks like it has a weird peak over here. What is that? We'll talk about that. ठीक है? This beach वाला state is what we call an unstable state. It's a high energy state and exists for a very short time. And इसके बाद ही it's like that, you know, you're at that peak and it can go either way. थोड़ा सा धक्का दो इस तरफ चला जाएगा, नहीं दो धक्का तो it will go back to that initial thing. So think about it like that. This is called the activation energy. Okay, this whole thing is called the activation energy from here to here specifically, ठीक है। And इस state को हम लोग बोलते हैं transition state या activated complex. यही चीज NCERT, this is directly from NCERT. Okay, we've got A and B and say they are forming all these bonds. Okay, it wants to form AB bonds, but it also has these bonds. This is all theoretical, ठीक है। This is highly theoretical, okay। And if you remember, there was a 5 carbon का transition state in SN2 reactions. Do you remember this SN2 reactions के बारे में? Just give me a thumbs up there, yeah. Mohammed ji, what were you saying? I didn't catch that. Right? There are some reactants, there are some products. There's a SN2 में there's a 5 like an activated complex, right? 5 bonds वाला जो है state. This is the same thing. This is that transition state or complex activated complex. And remember that was a one-step bimolecular reaction. Bimolecular मतलब वहां पे भी हम लोग, in fact, we were talking about the order being 2, ठीक है? The order was 2, ठीक है? वहां पे भी हम लोग kinetics की बात कर रहे थे. Similarly, SN1, what is 1? That's the order. And this is a 2-step reaction. So in fact, in a way, we have been talking about chemical kinetics. ठीक है? SN1, SN2 reaction में भी chemical kinetics की बात हो रही थी. It's just that some people may not have called it out. But if you have studied from me, मेरे जो sessions हैं on stereochemistry and halo, I've mentioned all this. ये तो मैं वहां पे भी बोल चुका हूँ. खैर, what did Arrhenius say? The energy required to reach that activated complex is known as the activation energy. ठीक है? So you're going from here to here. This distance on this axis, on this y-axis, is the activation energy. ठीक है? That's it. That's it. As same as that. That's straightforward. But what do these points mean? ये point 1 and this point 2, what does this have to do anything? Any inputs on what this could be? People on the chat, please get active. बताइए मुझे, what do you think this means right now? इन दोनों के बीच में क्या फर्क है? Yeah, what does it have any sort of bearing on anything? देखिए, you've learned this, that difference in potential energy. So there is no way of knowing कि इसकी एनर्जी क्या थी, उसकी एनर्जी क्या थी, but difference of energy is possible. Where have you heard that before? Internal energy, enthalpy. We'll talk about enthalpy. क्यों? क्योंकि यहाँ पे gases भी involved है. Internal energy works, but enthalpy accounts for gases as well, right? So we'll talk about enthalpy of a reaction. That's what this graph is showing. Also, इसमें यही चीज छुपी हुई है. Delta H, you remember, was summation of the enthalpy of products minus summation of the enthalpy of reactants. This is from thermo. ये आप लोग बहुत डिटेल में आराम से पढ़ चुके हैं. Again, you can go to my sessions. Yeah, these are my sessions right over here. इस पे आप जाके देख सकते हैं. Let me type that out. ये सब उसमें भी है. It is on the description, but you can check this out as well. Right. So this has sessions from thermo. It has sessions from everything else that you need to understand this. Okay. The thing with 12th standard chemistry is you need to do 11th standard chemistry to be able to understand it. Anyway, so I can, from that graph, I can figure out if a reaction is endothermic or exothermic. How can we do that? How can we do that? If the final enthalpy, is lower than the initial enthalpy. Like, look at this. Here, H final minus H initial is negative, right? Because this is lower. H final is lower than H initial. I can say products, reactants, same चीज है, ठीक है? Which means delta H is negative, which means this is exothermic reaction हो गया. That's it. That's it. It's as simple as that. Look at this. इस एक ग्राफ में सब चीज छुपी हुई है. It's very straightforward, not complicated at all. So similarly, I could also have another sort of a reaction. Now here, HI is lower than HF, which means that delta H is positive, and this is an endothermic reaction. See, from this graph, you guys have any doubts in this graph का क्या मतलब है? I am plotting energy, potential energy, क्या bonds ना? Energy is required to break bonds. Energy is released when bonds are formed. है ना? वही potential energy की हम लोग बात कर रहे हैं. That and progress of reaction. मतलब this is Q. This is somewhere in the middle. Okay. This is again a very theoretical idea. बार-बार मैं बोल रहा हूँ, right? And that's what we've got right here. Activate complex में सब bonds बने हुए हैं theoretically, right? All bonds are formed, nothing is broken. Okay, that's the general idea. You have broken some bonds, and there is no activated complex is basically the maximum energy state. बन रहे हैं, टूट रहे हैं, इससे ज्यादा जरूरी तीसरा. We don't know, to be honest. We don't know what is happening at the activated complex, but we can measure the energy of the activated complex. Okay, so we assume that there is some complex जहाँ पे जो है सब चीजें they are in transition. मतलब कुछ bond बन रहे हैं, कुछ टूट रहे हैं. इसीलिए there's a dotted line. If you noticed, it's a great question. If you noticed, I'm on slide 16. Now let me go back to the slide which had this idea. यहाँ नहीं, इससे और पहले था. You see, it's a transition state. मतलब कि some bonds are breaking, they're forming, we don't know, but it is a high energy state. Dotted line मतलब कुछ ये टूट रहा है, वो बन रहा है. Both of these things are happening. Some molecules में टूट रहे हैं, कुछ molecules में बन रहे हैं. Overall picture ये है कि भाई that's the high energy state. Okay. So as you get past that point, if you provide a little bit more energy, you have crossed the threshold. You have crossed the threshold. Okay. Threshold किस चीज का? Reaction को आगे जाने का, right? Now, yeah, we figured this out. Now this is interesting. ये सब अभी बात हो रही थी एक डायरेक्शन में रिएक्शन के. All of those reactions are going in the forward direction. What if there are reactions that go backward as well? पीछे उल्टा भी होता है. You know this, right? N2 plus 3H2 giving you 2 ammonia, something like this. In this case, you have an activation energy for the forward reaction as well as the backward reaction. How do you find out the difference? Simple चीज है. Your reference point is the same. The activation energy will be with respect to the topmost energy. What is this? The transition state की energy, right? Transition state energy के reference से होगा. So if it's a forward, then what are you starting with? I'm starting with reactants, and I want to get to here. So this difference is going to be the reactant. This is going to be the EA. उल्टा है तो क्या होगा? Then you're starting with products, right? If I'm starting with products and I go backward, again my reference is this. So this distance now becomes the activation energy of backward reaction. Any doubts on this? तीसरा, are you good with what I just told you? Any doubts on this? Is an extremely important idea. ठीक है, फॉरवर्ड और बैकवर्ड रिएक्शन की एक्टिवेशन एनर्जीज आर ऑलमोस्ट ऑलवेज डिफरेंट डिपेंडिंग on where you start from. ठीक है, the end point will always be the activated complex, which is the EA, ये top वाला एनर्जी वाला चीज. The idea being, हमेशा you can only measure difference in energies. Absolute energy measure आप नहीं कर सकते हो. That's just not possible. ठीक है. So enthalpy change can also be expressed in terms of activation energy. This is a little bit weird. EA minus EAB, how will you do that? Yeah, देखो उसको ध्यान से देखो. If you go back here, activation delta H क्या है? It is the difference between this and this. Okay, ठीक है. So modulus of EA minus EB, well, not modulus, let's not put modulus. Let us say कि forward minus backward, right? Activation energy of backward reaction. This is always going to give you delta H. क्यों? अगर ये पॉजिटिव है, ये जो है और भी ज्यादा पॉजिटिव है, then subtract this will give you a negative number, which is fine because delta H here is negative. You see, this is a cool क्या बोलते हैं, result of just what you've seen in the graphs. Okay, so delta H is EA forward minus EA backward, a cool result. So जितना ज्यादा हाइट हुई उतना ज्यादा एक्टिवेशन एनर्जी हुई, और अगर हाइट ज्यादा हुई मतलब मुश्किल होगा रिएक्शन करना, है ना, जाहिर है. In that, even if you look at the maths, what does this mean? इसका मतलब क्या है? इसका मतलब है कि भाई this is like, अगर मैं टेम्परेचर कांस्टेंट रखूं, let's say T is constant, right? So the variable is X, variable is EA, right? So K equal to some constant A times e power minus X. E power minus X एक्सपोनेंशियल डीके, है ना. टेम्परेचर कांस्टेंट रखा है. अगर x बड़ा हो गया तो भाई जल्दी डीके करेगा और जल्दी करेगा और जल्दी करेगा. दिस इज से x इक्वल टू 10, दिस इज 20, दिस इज 30, दिस इज मे बी x इक्वल टू 5. तो अगर यहां पे एक्टिवेशन एनर्जी ज्यादा हुई, देन द k वैल्यू इज गोइंग टू बी लोअर. यू फॉलो दिस? डू यू अंडरस्टैंड दिस? दिस इज ओके, राइट? जस्ट लुक एट द मैथ. It looks exactly like e power minus x. E power minus x is exponential decay. अगर e power x होता, e power x would be like this, right? But this is e power minus x का ग्राफ. ठीक है, तो एक्टिवेशन एनर्जी ज्यादा मतलब धीरे होगा भाई रिएक्शन. ठीक है, I told you already there is something called a threshold. If you get past the threshold, you have provided threshold energy. What is the threshold? It is that topmost point. उससे थोड़ा सा एनर्जी ज्यादा. It is just a little bit of energy more than the activation energy is called the threshold energy for the reaction to proceed. ठीक है, that's it. I'll give all these slides to you. It's not a big deal at all. You're saying you are here. Okay. Now you have to give energy more than the activation energy for the reaction to proceed. All right, cool. Here's a quick question. The activation energy for a simple chemical reaction A giving B is EA in the forward reaction. Now activation energy for the reverse reaction क्या होगा? सोच के बताइए. Take 20-30 seconds, but this is an important idea. What do you think? Please let me know. बताइए. बाकी दोस्त कहाँ गए? कृष्णा कुमार जी, चंद्रशेखर जी, नमस्ते. आदित्य, पुण्या, नीतू. Do you guys come from Discord? Where do you guys come from? Where do you guys get notifications कि यहाँ पे आना है? Or I know. I think I pinged on the Telegram groups as well, on the JEE and the NEET ones. All right, great. Oh, come on, check this out. Is this question difficult at all? Is it tricky? What do you think? आपको क्या लगता है? मुश्किल है क्या? Doable तो है. Hi, Bong Music. Is that Bengali music or is it something else? What do you think the answer to this is? बताइए बताइए. This is easier than it looks. The activation energy for simple chemical reaction is EA in the forward direction. Backward में क्या हो? किसको मालूम क्या होगा यार? How do I know क्या होगा? I don't know. I have no way of knowing. It can be either. देखो, I have taken two cases. Okay. In this case, what is happening? In this case, delta H is positive. In this case, delta H is negative. और डेल्टा एच विल ऑल्सो बी जीरो. आई हैव नॉट कंसिडर दैट केस. ठीक है, वो भी कर लेते हैं भाई, वो भी कर लेते हैं. ठीक है, डेल्टा एच इज जीरो, रैंडम केस. नाउ इन ऑल ऑफ दीज केसेस ये वैल्यू है, ईबी क्या होगा, ईबी यहाँ पे कम हो जाएगा, ईबी यहाँ पे ज्यादा हो जाएगा. सो इट कुड बी एनीथिंग, इट कुड बी एनीथिंग. देयर इज नो वे ऑफ नोइंग, देयर इज नो वे ऑफ नोइंग. या है ना, इट कैन बी लेस देन और मोर देन. हाँ एग्जैक्टली तीसरा. या गुड 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 गुड. ठीक है, वन मोर क्वेश्चन. ये एम्स 2003 का सवाल है, व्हिच मींस दिस वर्क्स फॉर बोथ जेई एंड नीट एंड आल्सो जेई एडवांस. इन फैक्ट जेई एडवांस भी. ठीक है, the potential energy diagram for a reaction R given P is given by here. Delta H naught of the reaction corresponds to the energy what? You've got A, you've got B, you've got C. Okay. इनमें से what is going to give you the delta H naught value? बताइए. Music साहब. What kind of music? R.D. Burman was great. What other great Bengali composers? Papi Lahiri, one with all the bling. Khair. How do you do this one? Yes, Huzaifa. Huzaifa, you think it's A? I feel that A is the activation energy. EA is going to be this. Okay, EA of the forward reaction. Okay. What about B? B will be EA of the backward reaction. So, in fact, delta H naught will be, it will be A minus B. I've given you the formula, but you don't need any formula. ये तो आप देख के कर सकते हो. क्यों? Delta H naught is this distance, which is directly C, no? है ना? Because see, यहाँ पे है reactants, यहाँ पे है products. And what is delta H? What is the definition of that? Go from first principles. It is summation of H of products minus summation of H of reactants. So since products हैं यहाँ पे, reactants हैं यहाँ पे, it is clearly just the value C, which also happens to be the option C. ठीक है? So the answer according to me is going to be C, which is also the same as A minus B. And this happens to be a reaction where delta H is negative. यानी कि exothermic reaction. So with this idea now you're sorted. अभी आप ये चीज properly समझ गए हो. ठीक है? भावना, thank you. Huzaifa, you good? Yeah? Do you understand how we got this? All right. All in one. Yeah, Teethraj, good job. Exothermic, absolutely. C is the right answer. All right. Now this may look scary, but this is the most beautiful thing about this chapter. Okay. Maxwell, Boltzmann statistics and Arrhenius theory. Looks scary. It's not. Don't worry about it. Okay. In general idea ये है कि there are many particles moving with many different velocities. But there is, if you were to pick one representative velocity, वो कौन सी होगी? You remember there was something called VRMS. आपको याद आ रहा है? थोड़ा याद आ रहा है? कुछ VRMS वाली चीज थी. Right? There was a graph, एक Gaussian curve था, इस टाइप से दिखता था. Right? Here you had fraction of particles. Have you studied this at all? या तो अगर आप, if you're going in 12th right now, you will study it in KTG. If you are studying in 11th, then ये चीज आप हो सकता है आपको ऑलरेडी इसको जानते होंगे. Now velocity से आप एनर्जी भी निकाल सकते हो. Why? What is energy? It is half m VRMS square. So what is this? V is the velocity of individual particles. हाँ, देखो जो A2 और B2 molecules है, they are whacking each other at very high speeds. They are moving around at very fast velocities. And I want one represented velocity. ये जो पूरी चीज है, उनके अलग अलग पार्टिकल्स की अलग अलग एनर्जी होती है. स्टैटिस्टिक्स का यही मतलब है ना कि बहुत ज्यादा डिफरेंट पार्टिकल्स हैं और बहुत ज्यादा डिफरेंट चीजें. एंड बट आई नीड वन रिप्रेजेंटेटिव एनर्जी सो दैट आई कैन मेक माय कैलकुलेशंस. वहां दैट इज वेयर दिस आइडिया स्टैटिस्टिक्स से हम लोग डिराइव करते हैं. ओके, लेट्स टेक दैट वन वेलोसिटी, लेट्स टेक दैट वन एनर्जी. ठीक है. यहीं पे लिखा है स्लाइड में, all molecules in the species don't have the same kinetic energy. It's difficult to predict the behavior of only one molecule. So we can use statistics to predict the behavior of a large number of molecules. Large मतलब कितना? 1 mole or so, right? So without going into too much detail, you will plot the fraction of molecules. Okay, distribution of energy. इसका क्या मतलब है? इसका ये मतलब है कि देखो, maybe something like 0.1, 0.2, 0.3. तो 0.3% approximately, it need not be this. 0.3 मतलब around 30% of all molecules have this kinetic energy. How do I know? Because they have the same velocity. Okay. VMPS हो सकता है बिकॉज ये बिल्कुल टॉप पे दिया है. टॉप मतलब मोस्ट प्रोबेबल वेलोसिटी. हैव यू स्टडीड ऑल ऑफ दिस और इज दिस ग्रीक एंड लैटिन टू यू? आप पढ़ोगे, डोंट वरी, व्हेन यू डू KTG. इफ यू वांट टू स्टडी राइट नाउ देन यू गो टू दिस बेंटो लिंक जो पिन लिंक पे है, वहां पे जाके स्टेट्स ऑफ मैटर पे जाइए. आई हैव टॉट ऑल ऑफ दिस. ठीक है, ओके. Chat has gone a bit quiet. I understand this topic is a little bit complicated, but the general distribution of energy of all particles is this. Okay, the representative I will take as this most probable kinetic energy. Okay, which comes from VMPS. What is VMPS? Root under root 8 by pi RT by M. याद है ये वेलोसिटी ये हो गई. ठीक है, सो अगर हाफ mv स्क्वायर करोगे तो क्या हो जाएगा? लोग खुद ट्राई करके देखो. It is not needed in chemistry, but maybe you will need in kinetic theory of gases in physics. ठीक है, the peak of this curve represents the most probable kinetic energy, and the kinetic energy is the maximum fraction of molecule. So think of that as the energy. देखो मैंने 1 मोल गैस ले ली, where to have in container this bottle of water. Ooh, looks cool. Anyway, does it look? Anyway, it looks funky in this white light. खैर इसके अंदर अगर गैस है, 1 मोल गैस है, so that's fix the volume. उसमें कितनी एनर्जी है? That energy depends only on temperature, but it will have different energy of different particles. But what is that energy that depends on temperature? इसकी हम लोग बात कर रहे हैं. Why am I talking about all this? Because भाई ये जो था ना, in all of this, I am trying to say कि what happens if you change this temperature? If I change, क्या हुआ? तो लिख नहीं रहा. एक मिनट, just give me a second. This is lagging a little bit. I'm just going to close this and open it up, and nothing's going to go away. Okay, hold on. Control Shift F5. Okay, now Control Alt F5. That should work. Did we skip a slide? All right, this should be better. Hold on. Let me get our chat right back here. Cool. What are you talking about? Yes. We want to change. अरे रुक जाओ, इतनी जल्दी मत करो change. We want to change this temperature and see what happens. If we change the temperature, what will happen? The energy will change. That is what we are trying to get to. ठीक है, टेम्परेचर बढ़ाने से होता क्या है? What is the main thing that happens at the molecular level when you change the temperature? ठीक है, okay, cool. All right, maxima of the curve, it moves to a higher energy value when temperature is raised. इसका क्या मतलब हुआ? हाँ, think about it like this. I've got some particles moving a little slowly at some temperature. मैं जैसे ही टेम्परेचर बढ़ाता हूं तो क्या होता है? टेम्परेचर बढ़ाने पे something interesting happens. टेम्परेचर बढ़ाने पे particles start moving faster. If the particles start moving faster, then this is what will happen. No, think about it like this. Okay, यहां पे थी मेरी most probable velocity. It moves to here. Okay, let me use different colors. It is easier to understand. Look at this green curve, green line wala curve. This is at a higher temperature. Okay, do you agree with this? Just give me a quick thumbs up in the chat. Okay, if you understand this. ये तो बहुत सिंपल है, समझने की बड़ी बात नहीं है. Particles moving at some velocity, vibrating, translating, सब कुछ. मैंने टेम्परेचर बढ़ाया, they start moving at a faster velocity, and the moment they do that, that means this curve should move to the right. By pushing this curve to the right, you will see I've also flattened the curve. Why? Because the overall thing क्या है? The area under this curve is constant. Why is area constant? Because देखो यहाँ पे है fraction of molecules. अब sum of total fraction तो 1 ही रहेगा ना. Fraction कितना है? If it's 0.3, this will maybe become 0.2, but it spreads out more. इसका क्या implication है? This is the single most important thing in this topic right now. इसका implication ये है, you can see that there are now more particles above my threshold energy, which is activation energy. Hence, वो reaction goes faster. This is the main thing about this graph right here. I'll repeat two things. हमने टेम्परेचर बढ़ाया. टेम्परेचर बढ़ाने पे the curve flattens out and spreads out. Flatten क्यों हुआ? Because the area has to be the same. और spread क्यों हुआ? Because the velocity has to increase. ये सब मैंने बहुत डिटेल में पढ़ाया है states of matter. but since that's not in your syllabus, इसलिए I'm teaching it to you here again. Okay, if that happens, the activation energy stays the same, which is right here, over here. This was the, in yellow, was the fraction of particles greater than activation energy. Now, yellow plus green is the fraction when I go to T2. So now I have more particles that are above that threshold energy. If there are more particles above the energy, they will react. And hence, at a higher temperature, the reaction goes at a faster rate. ये है इसकी theory. Any doubts, any questions on this? Please let me know if you have any doubts. Okay, ये काफी जरूरी है. ठीक है? So, by increasing the temperature, you're increasing the fraction of molecules that collide with energies greater than the activation energy. यही सब चीजें लिखी हैं यहाँ पे. Now, this is the theory behind why this happens. Okay? Now, do you want to put some maths to it? Let's do that. Let's put a little bit of math to it. By increasing the temperature or by decreasing the activation energy, by both of these, K increases. Okay, two things. So, I either increase T or I decrease this. Right? इसको डिक्रीज कैसे करेंगे? We'll see. When we do catalysis, you will understand there is a way to actually reduce the activation energy as well using catalyst. ठीक है? We'll do that then. इसको कैलकुलेट कैसे करोगे? या तो आप ग्राफ से कैलकुलेट कर सकते हो, और you can calculate the activation energy by measuring constant K at two different temperatures. We'll see how to do that. ग्राफ से कैसे करोगे? Let's look at that first. ठीक है? Here I've got K equal to this. Let's take log on both the sides. If I take log on both the sides, I get this awesome equation which is y equal to minus m times x plus c. है ना? Y equal to mx plus c तो straight line होता है. Straight line normally ऐसा होता है, ऐसा होता है. But this straight line is going to be a little different because इसका slope negative है, इसलिए ऐसा हो जाएगा. ऐसा हो जाएगा मतलब ये हो गया आपका c. This is the constant c, and the slope is going to be minus m. What is x here? X is analogous to 1 by t. What is y? Y is analogous to ln k. So हम प्लॉट कर रहे हैं इस एक्सिस पे ln of k, और इस एक्सिस पे हम लोग प्लॉट कर रहे हैं 1 by temperature. 1 by temperature, which is why sometimes students get confused. 1 by temperature. So temperature बढ़ाने से तो बढ़ना चाहिए ना? Yes, you just do the math. If you increase the temperature, k will increase. Obviously, because 1 by k साथ reduce कर रहा है, तो 1 by t साथ reduce कर रहा है, t के साथ बढ़ेगा. If this math seems quick for you, we'll do 1 or 2 questions. आपको समझ में आ जाए, कोई बड़ी बात नहीं है. ठीक है? This is the y equal to mx plus c minus m. This is x. ठीक है? And this distance here is c, which is the intercept, which is ln a. Cool. Any doubts here? Are we good on this? Is okay? Yes, absolutely right. Absolutely right, teacher. बिल्कुल सही. तो इससे हम लोग ये कैलकुलेट कर सकते हैं. तो चलो एक क्वेश्चन है आपके लिए. इसी आइडिया पे एक क्वेश्चन ले लेते हैं. The rate constant of a reaction is measured at different temperatures T, and the data are plotted in the given figure. The activation energy of the reaction in kilojoule per mole is what? Please बताइए. What is the activation energy? जो आपको मैंने अभी पढ़ा है exactly उस चीज पे सवाल है. By the way, I don't tell you, but this is from JEE Advanced. I think 2003 or something. So all the questions I do for you are either from JEE Main, JEE Advanced, NEET, AIPMT, एंड और क्या है, एम्स. सारे सवाल मैं क्लास वहीं से करता हूं, बस आपको बताता नहीं, क्योंकि आपको बता दूं आप लोग डर जाओगे. यू विल गेट स्कैर्ड. दैट्स व्हाई आई डोंट टेल यू. बट इफ यू आर सॉल्विंग दिस, यू आर सॉर्टेड. हरीश जी, विच पार्ट वाज कॉम्प्लिकेटेड? प्लीज बताइए. आई विल रिपीट. व्हाट पार्ट? थोड़ा बताओ. ट्राई एंड सॉल्व दिस क्वेश्चन एंड यू विल बी एबल टू फिगर इट आउट. इस क्वेश्चन के थ्रू लेट्स सॉल्व इट. Harish, elaborate what it is that was difficult to follow, and I'm here. Here are your options, okay? 2 by R, 1 by R, R and 2R. Rate constant, activation energy. देखो एक सिंपल बात है. Activation energy should be a function of R, right? Because R की यूनिट क्या है? R की यूनिट है जूल पर मोल केल्विन. Activation energy की यूनिट है जूल. So, if I multiply R with temperature, then I will get मोल पर और जूल पर मोल, है ना? यूनिट से देखो. अगर यूनिट्स एंड डायमेंशन देखोगे तो you can cancel out A and B. This does not make sense, okay? Because both of these have the unit per joule. This is joule and mole on top actually, right? ऐसा हो जाएगा, which is not correct. So dimensional analysis आप दो ऑप्शन हटा सकते हो. How do you do this question? हरीश जी, yes, last slide जो आप बोल रहे थे ना, last slide मतलब ये, correct? This was the last slide. उसी पे हम लोग क्वेश्चन कर रहे हैं हरीश. Try and solve this question. You'll be able to figure that out as well. Okay. Excuse me. I'll go over that one more time, Harish, if you like. Let's solve this question. A and B eliminate. Exactly. So how do we solve this यार? इसको कैसे किया जाए? देखते हैं. I have this form of the equation. I have, yes, exactly. I have this form of the equation. But this form of the equation is not useful. I'm going to mark this as not useful. Then what is useful? Take log. Take log on both sides. Okay, natural log लेते हैं. So Harish, यहाँ पे देखिए. Log लिया, log लिया. I have just used a simple property that log AB is log of A plus log of B. ठीक है? And hence ये जो है e पावर माइनस EA by RT just becomes minus EA by RT. L and A और ये separate हो जाते हैं. ठीक है? तो नेगेटिव साइन यहाँ पे आ गया. Okay. Now this is a straight line and this intercept here is L and A. And this slope right here is minus EA by R. And look at this. Would you look at this? I have the full value of y, which is ln k, and the full value of 1000 by t, which is this. So I can get minus EA by R. I can get the slope. ये हम लोग यहीं डालेंगे. Harish, you follow? This is what we are doing here. We're just using the straight line equation, y equal to mx plus c to solve it. And in this case, I'm only focusing on the slope m. Slope is minus EA by R because I'm plotting 1 by t versus ln k, right? So this is your constant and this is your minus m. All right, what do we do next then? So minus EA by R is going to be equal to 10 power 3 by t into ln k. Now, how do I get ln k by t? Dekho, when ln k changes by 10, delta ln k is equal to 10. Then delta of 1 by t is 5. You see that? You see that? Yes, दिख रहा है ना? In fact, it's a negative number. When this is this, ये negative है ना? Negative 5. That's fine. Negative 5 है. ठीक है. Cool. इसलिए this negative sign I've put here itself. Okay. सही है. So now I get a simple straightforward thing. 10 by 5 into 10 power 3. Yeah, don't forget this 10 power 3. What happens here is you get, oh, R दूसरी तरफ चला गया, ये 2 हो गया. So this is 2R into 10 power 3 joule, which becomes 2R kilojoule per mole. And they have asked you the answer in kilojoule per mole itself. So you're sorted. है ना? Harish, समझा? Teethraj? Yes? So the answer to this question is going to be 2R. It's a nice question. Straightforward, but you need to know how to start this question. इसको शुरू कैसे करना है, you need to be confident about it. Yeah, that's the main thing. Harish, I hope you understood this as well. Okay, cool. What is the other way to calculate the actuation energy? This is also the other popular way. This is quite popular. वो पहला वाला पार्ट ज्यादा आजकल पूछते नहीं है, बट इससे हमेशा बार बार आते रहते हैं. जेईई मेन में आया था, नीट में भी आया था. Right? Take it at two different temperatures and subtract these two equations. What will I use? I will use that ln A minus ln B is equal to ln A by B. This is what I will use now. ठीक है? So when I subtract both of these, see I get ln K2 by K1. On subtracting this, I get this expression. ठीक है? Then last part, what I will do is I will say that ln A equal to 2.303 log of A. क्या हुआ? हाँ यार, this makes sense, no? I'm changing the base from E to 10. है ना? Log to the base E is changing to log to the base 10. You have to multiply 2.303. अगर ये आपको complicated लग रहा है तो यार थोड़ा सा तैयारी करो. Okay, ध्यान से करो. E is 2.78 to the power 2.303 is equal to 10. ये सब आपको मालूम होना चाहिए. ठीक है? E power 2.303 equal to 10. You take log on both sides, you get the same thing. ठीक है? Okay, great. Change of base log और थोड़ा सा मैथ्स है, ये करना पड़ेगा आपको. You have to do this if you're converting from ln to log. That's it. This is the expression that you need to know. What happens अगर टेम्परेचर बढ़ाते हैं. Now look at it. If I change यहाँ पे T2 to T1, क्या होगा, क्या होगा? This is what tells you that 10 degrees पे डबल हो जाता है रिएक्शन रेट. Which means कि ln2 और log2 is equal to EA by 2.303 R into some 10 degrees ना, तो ले लो 310. So you do 10 by 310 into 300. In fact, if you solve this, you will get EA to be somewhere around 50 something kilojoule, ना 55, 54 kilojoule, ऐसा कुछ मिलेगा आपको. If you solve this, so you can find that, use that as an expression. Try करके देखो. Yes, yes, absolutely. It is for JEE, it is for NEET, it is for JEE Advanced, it is for NEST, it is for IIT, सबके लिए है भाई. तो थियरी इज द सेम फॉर ऑल ब्रो, बस ये कि क्वेश्चन के टाइप थोड़े अलग होते हैं. कूल. What is, yeah, man, ask Titraj and his friends. I've been teaching NEET on the NEET channel for some time, and I've been and the same videos have helped people in JEE Advanced as well. Yeah. Why are you retracting your comments? कुछ गलत नहीं बोला आपने, सही बोला. What is the activation energy for a reaction? Now see, instead of 10 डिग्री सेल्सियस हमने 15. हाँ, यू आर राइट तीर्थराज, थोड़ा थोड़ा कॉम्प्लिकेटेड होता है, बट आई टेल यू हाउ डू इट क्विकली. तुरंत करेंगे, बिकॉज अगर एमसीक्यू है तो तुरंत करेंगे, अगर न्यूमेरिकल एंट्री का थोड़ा एफर्ट लगेगा, बट विल डू इट क्विकली. What is the activation energy for a reaction if the rate doubles when the temperature is raised from 20 डिग्री सेल्सियस टू 35? मतलब 15 डिग्री सेल्सियस का चेंज हुआ, राइट, और रेट हो रहा है डबल. कैसे करोगे इसको? और 4 ऑप्शन दिए हैं, ठीक है. इफ आई वर टू गेस, इट इज ईदर दिस और दिस, इट इज नॉट दिस. 3. अगर एक्टिवेशन एनर्जी इतनी ज्यादा होती, यू हैव टू गेट अ फील ऑफ द नंबर्स. ओके, आई डोंट नो इफ यू रिमेंबर दिस और नॉट. अगर हम लोगों ने बात की थी व्हेन वी स्पोक अबाउट सरफेस केमिस्ट्री, आपके सिलेबस में भी है नहीं, बट आई हैव टॉट दैट टू यू एज वेल. वी सेड दैट फिजिक्स ऑप्शन 5-10 किलो जूल का होता है. ओ, केमिज ऑप्शन इज 50 टू 200, 50 टू 100 और 50 टू 100, 150 किलो जूल का होता है केमिज ऑप्शन, केमिकल बॉन्ड फॉर्मेशन. 340 टू 269 बहुत ज्यादा हाई है भाई. दिस रिएक्शन नेवर हैपेंड. दिस इज अ वेरी हाई नंबर. So you have to get a feel of what the order should be. It should be either one of these. Okay. Since 10 के बजाय 15 डिग्री करना पड़ रहा है, तो you can kind of guess what is happening here. But ठीक है, let's try. R is 8.314, but I will shamelessly use 25 by 3 because it works. I've been given options. It is not a numerical entry question. I've been given options, so I will use 25 by 3 R. कोई फर्क नहीं पड़ता है. So use this expression. Tell me what you're going to do. Take 2 minutes to solve it. I'll give you guys 2 minutes. Try करो. And then I'll tell you quickly कैसे किया जाए. I'll tell you how to do it within 1 minute के अंदर कैसे करते हैं. I'll tell you. 1 minute, 30-40 सेकंड में I'll tell you how to do it. Timer 2 minutes. Please start. Try it out. So the main thing is, जैसे मैंने उसका बोला था ना, example, as an example. I'll solve that other one. How did I get 50? Same way you will be able to solve this as well. If I assume that rate double हो रहा है, तो ln2 हो गया. I don't like using log and all. ln is easy to use. You want to use log, you use log. जैसा ठीक लगे. ln2 हो गया ना, by r into 25 by 3. Okay. और ये if I take for the other thing, right? T1, T2 if I take to be 10 degree Celsius, 310, 300. This is the other calculation. Don't worry about this. Okay. Not this Q. This is important. ताकि अगर कोई नोट थे कि भाई क्या लिखा है, तो इन दोनों को मल्टीप्लाई करेंगे, इनटू 10 आ जाएगा, राइट? बिकॉज फर्क इसका 10 है. दिस इज जस्ट यू हैव वर्कड ऑन सीरीज एंड पैरेलल रेजिस्टर्स, राइट? यही तो करते हो आप लोग. You will subtract them, you will add in that case. You don't have to subtract, but idea same. You have to add those and multiply those. So that's what we are doing here. Get comfortable with the maths, guys. That's all you have to figure. ठीक है? So you multiply with 300 into 310 divided by 3 by 10. So I'll assume कि दोनों जगह 300 आ रहा है. So I will go okay 9 कर देते, 9 कर देते, 9 into 10 power 3 कर देते हैं. ठीक है, ये हो गया. Into 25 by 3, 25 by 3, let's leave with that. Into ln2 is 0.7. ठीक है. So now I have 8 into 9 approximately, 8 into 9, 8 into 10 कर लेते हैं. ठीक है, 8 into 10 because 8.3 into 9 into 0.7. So that is 70 into 10 power 3. Approximately ये हो गया. That is your answer over here. Is that correct? I have a feeling it's going to be a little bit off, but ठीक है. Let's see maths करके does it give me the same answer? Divided by 10, 9.3 into 0.693 into 8.314. Yeah, I took too many approximations. So, or I think I messed up the maths here. It is 80 into 7, ना? यहाँ ये मैंने miss कर दिया. It's not 70. 8 into 7 is not 70. 56. So this is very close. Actual answer is 53.582 kilojoule. I got 56. काफी है. Good enough, no? Good enough. So the approximation works, यार. हाँ पलक, how you doing? Yes. 1.6 10 power minus 4. Okay. Sure. What about the whole this thing, yaar? Titraj, that's good. Palak, what are you saying? I'm not able to follow you. वो ठीक है. Into 1.6 10 power minus 4 आ रहा है. Okay. So now you tell me the value of EA from there. Titraj, EA की वैल्यू बतानी है ना? EA की वैल्यू बताओ. कैसे करोगे? मेरा सजेशन ये है कि सब्स्टिट्यूट उतनी जल्दी मत करो. ठीक है. इसको ऐसे रहने दो, यू गेट 293, यू गेट 308, ठीक है। आई विल अज्यूम कि इन दोनों को सब्ट्रैक्ट करने में 15 डिग्री आ रहा है, राइट। सो लेट मी राइट दैट ओवर हियर। ये विल बी 0.7 which is ln2 into 25/3 which is r into 293 into 308 by 15. I will assume this 300 into 300, कोई फर्क नहीं पड़ता यार इससे, that's the beautiful thing. Now you actually multiply, see 308 and 293 कितना आता है? The actual value is 90244 and I've got 90000. What is the error? You see the error, 244 divided by 90244 into 100. Bro, error is 0.27% error. See, it works. So do this, please do this, Harsh. Hi. When you're doing these calculations, please do it like this, okay? You take this 293 into 300, it as just 300 into 300. चलेगा, कोई टेंशन नहीं है, because my error is 0.27%, not a concern. Even for JEE Advanced is not a problem. डिनोमिनेटर में 15 है, 15 से थोड़ी प्रॉब्लम हो जाएगी। चलो कैंसिल कर लेते हैं, हो जाएगा यार, कोई बड़ी बात नहीं है। 3 गुना 5 गुना, ठीक है। सो व्हाट आई हैव नाउ इज 0.7 into 5 into 9 into 5 into 9 into 10 power 4 divided by 3 into 3 into 9 again. Look at that. Life is good, isn't it? 9 फिर से आ गया, सब हो गया कैंसिल। 0.7 into 5 कितना होता है? 35 होता है। So this is 35 kilojoule. I got 35 kilojoule, bro, which is beautiful, isn't it? हर्ष, बात हमसे करो, ये सब यहां नहीं चलेगा। Okay, this is great. बात हमसे करो, please. Yeah. Here you go. 35 kilojoule is what I get from approximately 3536, which is very close to the answer. 34.7. Isn't it brilliant? It's okay, Shivansh. तीसरा समझ में आ रहा है? How you get this? Palak, Harsh, who else is here? Harish, Lyric, bhai kahan gaye? Shivansh, it's okay. This is how you do this calculation very quickly. It doesn't take more than a minute to do this calculation if you do the right approximations. Life में वही तो करना है. सबसे जरूरी चीज है कि don't substitute until the end. Okay? Okay? Please figure it out. And guys, please keep it civil in the comments. I don't want to be the class monitor. That's not my job. Yeah? You guys, please keep it civil in the conversations. I want the community to be supportive and encouraging of each other. If you can't be encouraging, it's better not to say anything. Yeah, let's focus on this. Let's focus on this. Guys, relax. I'm gonna have to put you guys in timeout. This is weird. Don't do this. I don't like doing all this. Focus on this. Okay? All right. The answer right here is 34.7 kilojoule per mole. Next question. The rate constants K1 and K2 for two different reactions are this and this. What is the temperature at which K1 is equal to K2? जल्दी से करो, ये भी कर सकते हो. It looks scary. It is not. It is not. Not. This is into. Okay. Point मतलब multiply कर रहे हैं. So look at this. What is this? ये 10 power 16 क्या है? This is A, which is the frequency factor, and that's right. Frequency factor की value बहुत बड़ी होती है. It is huge. It is very high. Okay. What is this? 2000 must be EA by R. 2000 must be EA by R. Would be 2000. Must be that. 1000 is 2000 by R. ठीक है. So we are saying that rate constant K1 and K2 are these values. What will be the temperature at which K1 equal to K2? Please try this out. Take 2 minutes. Palak, you're gonna go in a timeout because seriously, can't do this, bro. It's not my job to sit and be a class monitor here. Oh, गाली दे रहे हो क्या? What is all this? What is this? Not doing this, bro. Khair. Yeah, let's keep it going. Harsh, please, yaar, you also take it easy. Focus on what we have over here. Okay? सवाल पे फोकस करिए. लोग जो रैंडम है मैं देख लूंगा. आपको डोंट एंगेज इन रैंडम थिंग्स. ठीक है? Let's get to the point. All right. How do you guys solve this? 36 आ रहा है. Good job, please. Yeah. Let's focus on. तुम लोग आए पढ़ने के लिए. इंटरनेट पर लड़ाई करनी है तो किसी और से करो ना. यहाँ मत करो यार. It'll disturb you. I am not getting disturbed by any of this. भाई मेरा तो काम है. I have a thick skin. I get used to all this. But by doing all these things, तुम अपना मन खराब कर रहे हो. उसकी जरूरत नहीं यार. Ignore करो. Focus on what you need to get out of this, right? This short and awesome, powerful session. The only way to do this is to write down these things from first principles. ठीक है? फिर K1 और K2 की वैल्यू लिख लीजिए जो यहाँ पे this is given in the question. This is given. Okay. Now, what do I do? Do I divide these? Do I subtract these? Do I equate this? क्या करें हम? 1, 2 or 3. I've given you 3 options for these 2 equations. What do we do? क्या करें? Pranam Anjali ji, good afternoon. Please try this question out. Harsh, Palak, everybody who wants to solve it, please इसको सवाल करिए, इस सवाल को try करिए. I have a very high tolerance limit, but please, सवाल. Let's focus on the questions. Okay. What do? I've given you 3 options. Will you divide these 2 equations? Will you subtract them? Will you equate them? Tell me. मुझे निकालना है t की वैल्यू. And I've been given that K1 is equal to K2. अगर equal दिया है तो let us equate. No. What else? और क्या करना चाहते हो? Equate कर लो भाई. That's the easiest thing to do. Or I could also divide. I could equate or I could divide. Subtract करना भी चल जाएगा. I can do any 3 actually. I can do any of this. कुछ भी कर सकते हो, है ना? Shivansh, take your time. Take your time. ठीक है, take a minute. Timer 1 minute. Take a minute, try it. तीसराज, मैं ये बता रहा हूँ. You can do anything. तीनों करो. It's okay. Do any of them. You'll still get the answer. कुछ भी करो. This is the moral of the story. You do whatever you are confident with, but have logic behind it. ये सब सोचो. और एग्जाम के समय सोचने का टाइम नहीं है. सोचना अभी है. Okay, while you're preparing is when you are thinking. Think as much as possible. कोशिश करते रहो and get on with this. Okay? ठीक है? All right. I'll give you a minute. Timer's running. Take your time. Try it out. हाँ, तीसरा डिवाइड करो आप जैसा आपको ठीक लगे. शिवांशी, आप भी ट्राई करिए. आई एम वेटिंग फॉर यू. मिनट. कुछ भी कर लो तीसरा, क्या फर्क पड़ता है? यू फिगर आउट आगे क्या करना है. अभी तो कुछ भी कर लो ना. देखो, द थिंग यू हैव टू यूज इज e power x divided by e power minus y is e power minus x plus y. यही है एक्सपोनेंट्स का आइडिया, है ना? मैथ्स को तगड़ा करो आप लोग. दिस इज सिंपल मैथ. एक्सपोनेंट्स, है ना? तो इट डजंट मैटर विच वन यू डिवाइड. 1 by 2, 2 by 1, कोई फर्क नहीं पड़ता. इट डजंट मैटर, राइट? ईदर वे विल गेट फिगर्ड आउट. सो आई हैव चोजन, लुक्स लाइक मैंने क्या किया यहां पे, I have done K2 by K1. मैंने किया है डिवाइड, which will be equal to 1, which will then be equal to this, है ना? तो K2 by K1 के नहीं, K1 by K2 के, यहां मैंने उल्टा किया. I have done K1 by K2 over here, which is equal to 1, and then I've said, let's take this to the other side. Yeah, I have, if I divide both of these, I get 10 into e power minus 2000 by t is equal to e power minus 1000 by t. So I take 10 to the other side, I get 10 power minus 1 equal to this. This expression is after doing this. ठीक है? वही बताया था मैंने, माइनस प्लस का चक्कर है. ठीक है? Now what do we do? You can do it any way you like. You can do it any way you like. It doesn't matter. मैं आपको सबसे मेस्ड अप वे दिखा रहा हूँ, उसके बाद you'll figure it out. ये अगर कॉम्प्लिकेटेड लग रहा है, कुछ नहीं है. इसके बाद तो बस सब्ट्रैक्ट करना है. So you get this e power minus 1000 by t is 1 by 10. Right? अब क्या करें? अब ले लो यार एंटी लॉग. टेक एंटी लॉग नाउ. डू वी टेक एंटी लॉग? हाँ, एंटी लॉग लेना पड़ेगा. लॉग एंटी लॉग क्या करें? लॉग ले क्या? लॉग लेके एंटी लॉग ले. व्हाट डू वी डू हियर? लॉग और एंटी लॉग, व्हाट डू वी डू? क्या करें? एंटी लॉग मतलब 10 power something e power something to get there. No, I have to take log because I already have e. So let's take this. Let us take log. Okay. After we take log, you get e. You get this. So I have taken log. Log of this whole expression. Log of this whole expression. Log to the base what? Log to the base e, which is actually ln. Okay. ln of this whole thing. चलो. अगर मैंने ln ले लिया of minus 1 by 10, what does that mean? That means minus ln 10. That is minus 2.303. ठीक है? Which is what the right hand side is. Left hand side को as it is रख दिया है. Minus minus हो गया. Plus what is temperature is 1000 by 2.303 Kelvin. ठीक है? Cool. This is the answer right here. Yes, Shubhash, Trisaj, thank you for those answers. That's all you have to do. हम लोग को ध्यान से देखना है कि करना क्या है यहाँ पे। जो लोग लड़ाई कर रहे थे वो लोग चले गए लगता है बोर्ड ऑफ करके। हो क्या आप यहाँ पे? पलक, हर्ष, सीखने आए और सीख के को चले जाओ। अंजलि जी, डिड यू अंडरस्टैंड दिस? शिवांश, गुड जॉब। तीर्थराज, गुड जॉब। बी शुड बी द आंसर। चलो एक और सवाल। द प्री एक्सपोनेंशियल फैक्टर, कोलिजन फ्रीक्वेंसी या प्री एक्सपोनेंशियल फैक्टर ए इन आर्हेनियस इक्वेशन ऑफ अ फर्स्ट ऑर्डर रिएक्शन की क्या यूनिट होती है? बताइए। दिस इज अ 30-second क्वेश्चन, यू ईदर नो इट और यू डोंट। ट्राई इट, प्लीज ट्राई दिस। दैट्स आवर स्टाइल। हम लोग पूरा चैप्टर खत्म करते हैं जल्दी जल्दी जल्दी। वी सॉल्व अ फ्यू क्वेश्चंस एंड वी आर सॉर्टेड। वी आर सेट विद दिस चैप्टर। और कहीं पे कुछ पढ़ने की जरूरत नहीं है। और प्रैक्टिस चाहिए तो और टेस्ट ले लो, चलते रहो। ऐप है बायजूस की, डाउनलोड, डू स्टफ। गुड जॉब, गुड जॉब तीसरा शिवांश, लवली। Yeah, all right. What is the logic here? K and A have the same unit, and unit of K is per second because it's a first order reaction. That's it. सही है, सही है, सही है. Wonderful. बढ़िया. What is the effect of a catalyst? This is a simple idea. We won't spend too much time on this, but the broad thing is कि catalyst दोनों forward और backward reaction को effect equally करता है. मतलब कि it changes the activation energy of the reaction. ठीक है? There can be two types of catalyst. या तो activation energy कम कर दे या तो बढ़ा दे. हाँ, कम कर दे या बढ़ा दे. Either way. So it can either decrease or increase EA. Okay. अगर ये डिक्रीज कर रहा है तो इट मेक द रिएक्शन फास्टर, हेंस इज अ पॉजिटिव कैटलिस्ट। और अगर बढ़ा रहा है तो मेक द रिएक्शन स्लोअर। हाँ, देयर आर सम रिएक्शंस दैट आर रियली फास्ट, दे आर स्कैरी। फास्ट रिएक्शन मतलब बूम, एंड यू डोंट वांट दैट, यू डोंट वांट फास्ट रिएक्शन, यू वांट स्लो इट डाउन। इन दैट केस यू विल यूज समथिंग व्हिच इज कॉल्ड अ नेगेटिव कैटलिस्ट। दैट्स वन वे। अनदर थिंग इज कि देखो, देयर इज, आपने पढ़ा है क्या, पैलेडियम इज अ पॉइजन, है ना? इट डजंट लेट यू रिड्यूस ऑल द वे। BiSO4, ये पढ़ा है आपने ऑर्गेनिक केमिस्ट्री में, PDBSO4 यूज करो इंस्टेड ऑफ जस्ट BiSO4। सो जो है इसको पैलेडियम को पॉइजन कर देता है, तो इट स्लोज द रिएक्शन डाउन। सॉरी, BiSO4 इज अ पॉइजन। यू स्टडीड ऑल दिस इन ऑर्गेनिक, बट प्लीज डू दिस। या यस, यू आर राइट शिवांश, यूजुअली यू आर राइट, यू आर राइट, बट कभी कभी आई गिव यू एन एग्जांपल वेयर नेगेटिव कैटलिस्ट भी होता है। increases the rate of a reaction, negative decreases, and the better word to use here is inhibitor। ये सब surface chemistry में था, पर ठीक है हम लोग फिर से यहाँ पे anyway कर देते हैं because surface chemistry has been deleted from our syllabus, right? All right. So here is an example of a positive catalyst. What is the general characteristic of a catalyst? कि it does not really initiate the reaction, it just speeds it up। मतलब ये रिएक्शन को शुरुआत नहीं दे रहा है, बस बढ़ावा दे रहा है। बढ़ावा हिंदी में बोल रहा हूँ, बट इंग्लिश में स्पेसिफिकली इट स्पीड्स अप द रिएक्शन। बढ़ावा इज अ बैड रॉन्ग से, वो जो है इट स्पीड्स अप द रिएक्शन। एंड अ वेरी स्मॉल अमाउंट ऑफ कैटलिस्ट कैन कैटलाइज लार्ज अमाउंट ऑफ रिएक्टेंट्स बिकॉज सरफेस एरिया पर मास एंड ऑल दैट वेरी फाइनली डिवाइडेड का चारकोल, वो सब होता है। इज देयर इज सर्फेस केमिस्ट्री, यू वांट यू कैन रीड अप, इट्स ऑन माय बेंटो सेशंस। ओके, दिस इज एक्सट्रीमली इंपॉर्टेंट। इट डज नॉट इफेक्ट इक्विलिब्रियम एट ऑल। K is unaffected. Okay. KF, yes. KB, yes. But KF by KB, same. It reduces the time to get to equilibrium. मतलब कि अगर if I've got a reaction where यहाँ पे equilibrium हो रहा है, now instead of this, it will reach equilibrium faster. ठीक है? This is with catalyst. This is without. What am I plotting? क्या करें हम लोग? Concentration वर्सेस टाइम। किनेटिक्स के पहले चैप्टर में, पहले सेशन में सब बताया था आपको मैंने। ठीक है, कूल। ओ, जन पास में है। ओके ओके ओके, यस शिवांश, दिस इज पॉजिटिव। यस तीर्थराज, PDBSO पॉइजन, बिल्कुल सही, बिल्कुल सही। इट ऑल्सो डज नॉट इफेक्ट द गिब्स फ्री एनर्जी ऑफ द रिएक्शन। ओके, अगर स्पॉन्टेनियस है तो स्टे स्पॉन्टेनियस, नॉन स्पॉन्टेनियस है तो नॉन स्पॉन्टेनियस रहता है। ठीक है, ठीक है। सो इट डजंट डू एनीथिंग देयर। या so if a reaction is non-spontaneous, it doesn't make it spontaneous. That's what we're trying to say. हम लोग बोल रहे हैं एनर्जी में, it just changes activation energy, nothing else. That's very important. Okay. So it, बहुत लोग ये सब बोलते हैं ना कि अगर एक पहाड़ चढ़ना है तो उसके बीच में टनल खोद दो and all of that, same thing यार. So it reduces, I don't want to do all of that. You have heard that hundreds of times. It reduces the activation energy between the reactants, lowering the potential energy barrier. This is a technical term. Let's look at it from the point of view of a graph. We'll look at it. Yeah, this is the graph. So here, without catalyst and with catalyst. So you see, this is the change in activation energy. And there are questions on this as well. इस चीज पे सवाल पूछे जाते हैं, ठीक है? Similarly, this is a negative catalyst. Here, I've got E increases. Okay, cool. We good? Let's look at a quick question about this. The addition of a catalyst during a chemical reaction alters which of the following quantities? अब सोच के बताओ. I've just given you the answer a minute back. What do you think? This is very doable. I think it's very doable. Please try it out. We'll take 5 more minutes maybe. We should be done in 5-7 minutes. Should be good. Yes, Shivansh, बिल्कुल सही, बिल्कुल सही. What do you think about this one? मेरे हिसाब से it is just B, nothing else. I have been giving you questions with more than one correct, right? I'll get you questions with more than one correct next time. ताकि थोड़ा आपको effort लगाना पड़े life में. Yeah. It's not going to affect anything else. It'll affect the forward and backward activation energy. It'll affect both, na? I'm going to go back to this thing. You see here, this is EA forward. This is EA backward. It both are being affected, है ना? ग्राफ में देखो, ध्यान से समझो. ठीक है. How do enzymes increase the rate of the reaction? Biology वाला question. Enzyme क्या करता है specifically? And answer to this Shivansh already दे सकता है, दे चुका है. This is straightforward, right? Not this, it does not affect K. Yeah, this everybody does. So I don't think it increases the rate. Substrate enzyme complex तो बनता ही था, but that does not increase the rate of the reaction. Increasing से rate तो नहीं बढ़ता, it must be a lowering. So this is a straightforward question. You don't need to know what an enzyme does, okay? If it is increasing the rate, it can only do so by lowering the activation energy. और कुछ है ही नहीं. है ना? है ना? है ना? All of you सवाल आया था? नहीं आया. मतलब तीसरा NEET also is getting interesting. Yeah, absolutely. So there are more other theories that were developed, okay, which makes more sense, which is collision theory. हम लोग Arrhenius theory पढ़े थे. Now this has not been spoken of in too much detail in NCERT, but we'll talk about it a little bit over here. Okay. The main thing is मैंने 3 चीज बोली थी. Enough energy, right orientation, and there should be actual collisions happening. Like they have to physically collide each other. Right, enough energy and the right orientation also. ठीक है? ये kinetic theory of gases में आपने पढ़ा होगा in physics. Chemistry में से sadly हटा दिया गया. There are 3 things: A, EA, and some orientation factor which is a part of this, that जो collision frequency थी ना, उसी के अंदर it gets added on to it. ठीक है? There's a root or something कुछ आता है. ठीक है? Collision frequency Z है. So A is basically Z times what should I call this? I'll see the unit for this right here. Yeah. तो दोनों चीज जो है तुमको देता है totally. Sorry, allergies. Both of these ideas, the collision frequency and the orientation factor, contribute to A. Okay, multiply both of them and you get A. Collision frequency, by the way, is there on JEE Advanced. मैंने उसमें आपको solve किया है. If you want to look at the derivation of collision frequency, mean free path, you can check out my JEE Advanced sessions. They are on that bento link. If you're looking for this specifically, ये मैंने states of matter में किया हुआ है. Okay. Activation energy, as it was, not all collisions actually lead to an actual product formation. Some of them are below the activation energy, right? Which we saw using this Maxwell-Boltzmann thing, right? EA matlab ye, only the things that are higher than this actually have a chance of this happening. Baki to bhai nahi karenge. This is theory, you never know. Maybe somewhere from here also good reaction ho sakta hai, ho jaye. Possible hai, quantum tunneling, whatever, good things may happen. But right now at our level we are studying कि ठीक है, activation energy से कम है, नहीं होगा, ठीक है? And activation energy अगर बढ़ गई तो K हो गया कम, which is what says here कि inversely related to the rate of a reaction. Okay? तो ZAB times EA minus EART is the actual rate. This is the collision frequency of reactant. Orientation factor कहाँ गया? Orientation factor. Anyway, this tells you the rate constant for simple atoms and molecules. If you have complicated things like, you've got multi-step reactions, then things are not this direct. Okay, you have to do a lot more things. It's a little bit complicated because not all collisions actually lead to product formation. You know that in organic chemistry, in fact, अभी JEE Advanced का एक पेपर था जिसमें एक चीज थी कि steric hindrance की वजह से things get messed up. Even when you do I want to say SN2 reactions, if you have a bulky substrate, stuff doesn't happen. Yeah, bulky substrate, not gonna work. Or even if the nucleophile is bulky, it's not gonna work. So steric factors come into the picture. Okay. So अगर वो collide करे भी, very few collisions are actually effective. So all of the theories are good, but they sometimes fail as well. Okay, that was the last part about orientation. And yeah, so this is also important. Cool, that was it from me for today. Yeah, you need to have enough energy and they need to have it be greater than threshold energy. What is on your mind? Do you guys have any doubts? Anything you want to talk about? You're not PCB? What is your question? Shivang, I didn't understand. Shivang, you don't have any question. What do you mean? Did you ask a question? It did not come to me. There maybe a question got missed. आपने मेरे से कुछ पूछा क्या? You can ask any question यार. PCM, PCB सबके लिए है. This session is relevant for everybody. JEE, NEET, IIT, NEST जो भी एग्जाम दे रहे हो, CUET, कॉमेट के सबके लिए यूजफुल है भाई. Theory is the same. I teach a little bit extra, more above and beyond the NCERT. All right, cool. Khair, all this is not really in your syllabus as such, but ठीक है. The orientation needs to be good for things to get formed. Otherwise, it may not happen. All right, let's call it a day with this. And if you have any doubts, you can always reach out to me over here and I can add you to groups, discussion groups on Discord and Telegram where you can ask your doubts. If I'm free, I'll answer them. If someone else is free, a lot of students there, they'll help you as well. So that's it. With that, kinetics, chemical kinetics is done. What do you want me to do next? Do you want me to do electrochemistry next? Do you want me to do organic next? Do you want me to do inorganic next? Let me know in the comments. Do you want me to do some tutorial sessions? JEE के अलग, NEET के अलग, बताइए. I'm here, all ears. आपका feedback बहुत useful है. You can reach out to me on those bento links on Telegram and Discord. ठीक है? Thank you everybody for your time. I overshot my time by a few minutes. Yeah, but I think we are good. I think we are good. You don't mind that. So yeah, that's it. With chemical kinetics is finished. Let me know how the session went, how you liked it. Let me know in the comments. All right, see you around. Have an awesome Sunday. Tata. Thanks for joining in. Bye. If you're watching this on Sunday. If you're watching later, भाई आ जाओ live में. मजा आएगा ज़्यादा. You can ask questions. Bye.